Hi, my name is Frank Parth, and this is my presentation on a project that I did for data mining and analysis of the mine data for University of California, Riverside, CS235. So basically, I decided to do my project on the mining of EHR records and the analysis of them. Basically, an EHR record is an electronic health record, and it basically stores all the information about a patient within a hospital's EHR system, which is just the software that they use to store patients' information if you go to any given hospital or clinic. Some of the major ones are like Epic and Cerner and Allscripts, MedHost, NextGen, are the major suppliers, but basically, anytime you go to almost any medical practice, they're going to have EHR software when you get there. So one of the things that happened was, I think back in the late 90s, early 2000s, there were a few laws passed that allowed for the sharing of medical data. Due to that, all these kind of shops called HIEs, or Health Information Exchanges, popped up. And how they would work is basically all the hospitals within a given region, whether that be like city or county or state, would essentially send all their medical data in, and then that HIE would in turn send it out to other hospitals in the region. So if you were to go into one hospital and they find out you're allergic to penicillin, and you go into the other hospital and you're unconscious, and you have an infection, and they're trying to figure out what to use to treat it. They know what your allergies are, so they can kind of figure out what not to give you. So when that first started out, it was kind of a little bit of chaos because all the different EHR vendors had all their own APIs and ways of sending data, and so it would be a nightmare to actually connect those systems. Like an HIE wanted to get medical records from a hospital, it became quite a nightmare to actually have them sent in. And because of that, a standardization organization popped up called HL7. And it basically defined what would be sent, like the format. This is what you're gonna send. It would not necessarily define how to send it. There were standards about that, but it was saying this is what will be sent. So the first version was a little bit of a nightmare. It's called HL7v2. And basically, it contained a lot of information about the patient, the PID segment, the MSH who was sending it, So you'd have all these different segments that were delimited, a little bit confusing to interpret. So that worked well for a time being, but then essentially it came to the point where kind of someone somewhere said, why aren't we using XML? And so it went ahead and changed that. That, however, it worked great, and it still works. And believe it or not, people still use HL7v2. A lot of hospitals still use it. A lot of medical devices within a hospital still use it. But at some point, somebody finally kind of figured out, let's switch this to XML, and they started using what's called HL7v3, which had several different names and went through different iterations. It's clinical document architecture, CCR, CCDs, just a bunch of different kind of versions and types of HL7v3 of clinical documents, and they were great while they worked, but there were some issues that popped up eventually with those as well. So this is kind of an example. And so these can be rather large, and we'll get into that later, but basically said, this is a patient. And so that worked for a while, but the nightmare of kind of not just what to send, but how to send it was still there. And so IAG came along and said, this is essentially how you will send your data. And so it came up with kind of a workflow of different models for sending medical data. For the ones that HIEs usually work with, it's called the ITI, IT Infrastructure Framework. And most commonly, you're using XCSP, XCA, and PIX-PDQ for patient identification registration and querying. And so those are based on some kind of older, web services that use SOAP, and that was fine. You kind of send certain information about who you were and what you had, and the WSDL, or you call it WSDL, and send it in a SOAP envelope. So it worked for a while. Whether or not it was better, I don't know, but it's there, and people still use it, and it's kind of actually in the process of picking up steam still. But HL7 kind of turned around and stomped on it and said, you know what, we got something better. And so they came up with HL7 Fire. And even though it's still in trial, I think it's in STU, Standard for Trial Use 3 right now, it basically said this is what you'll send, and you can send it in JSON or XML. This is the structure of it, and this is how you're going to send it. It's a REST API. So it literally defined the structure of the REST API that a bunch of different software vendors decided to implement, and open source vendors as well. Thank goodness for that, because who doesn't like free software? And it kind of ensures that we're all using the same thing, because basically everyone is as cheap as possible in that industry, and so if somebody else does the work, they'll use it. So, this is a JSON example of something that got sent. And that worked great. So you could basically handle that really well. But because of some of the complications, I mean, things like maybe a birthday might be formatted differently, phone numbers, all that sort of stuff. You have to work with all different types of data coming from all different types of systems, and it's all formatted differently. So these things called interface engines popped up. The most popular are, well, now it's NextGen Connect, but it was formerly North Connect, Orion, Rhapsody, Clover. Those are some of the more famous ones. But essentially, they use a few different features. So, Mirth Connect is kind of my poison of choice. It kind of has a few benefits to it. It's built on Apache Camel for routing, so you can have the source sent to several different destinations. Maybe you want to write something to a database and then notify someone that happened, or send it to some other place, or you want to call an API and get a response from that API and use the data in that response in your next call to the next destination. So it's very interactive in how it can be put into in between different systems, and it's pretty easy to implement. It also uses queuing, so if a system goes down, it will store the messages until that system comes back online, at which point it'll automatically send them, or you can reprocess them on your own manually. It has filtering in case there's data you don't want, and there's a lot of need for that when you're dealing with clinical documents. Transformations, which is discussed, alerts, and you can even add your own, you can build your own custom library in Eclipse or IntelliJ or whatever the IDE you chooses, NetBeans, whatnot, and add those libraries to it, so it can call that, because it allows you to write code in the Rhino engine. It can be JavaScript or Java, and so it's very flexible in how you can do things. It is built on another library called Happy. So you have Mirth and Happy, but apparently they just want people to be in a good mood or something. But that natively handled HL7. So Mirth was built on a lot of these kind of like tried and true libraries that were kind of necessary to use in the industry. It supports all different types of connections. These are a few. I'm not going to name them off, but needless to say, if you need to build your own connection, you can do that as well. But because it supports HTTP, it supports kind of any kind of web service. So you have a lot of flexibility on what you want to send and how you want to send it. So with this in mind, the model that I chose to use was the HIE connecting to a homeless shelter. And so, a lot of times HIEs will connect to psychological clinics, everything. I mean, it'll, even like criminal justice, social services, they'll connect to everything. They just want data from everyone, so that they can, basically help their population as much as possible. So for this problem, basically what I was looking for is, how can you analyze if there is an instance of a disease or a condition of some kind within the homeless population. So this is connecting to an HIE in Colorado, and that sent in its medical data about homeless patients. And so kind of the question was, well, let's say you want to monitor if there's an outbreak of a disease of some kind, and then you can go in, the city can go in and maybe, help those people, hopefully help those people out and get them the care that they need. And so in this case, I just decided to use cancer. It's pretty well defined. And so that was kind of the example that I chose, but it could be used for almost any other, disease that's defined by any of the codings, and I'll get to that part in a moment. But basically, the way that I wrote it, it'll handle either CCDs or handle FHIR, messages, and it'll determine if there's an instance of that, and then it'll write out to a flat file to be processed later. So defining cancer was done by going through ICD-9, ICD-10, SNOMED, and LINC all provide their codes and the descriptions of those codes to you. So those files are rather large. There are a lot of ICD-10 codes, and they keep coming up with new ones, and SNOMED and LINC. And so I had to process those files, and I used OpenRefine to do that, to build a flat file that contained only the cancer codes, as well as their descriptions. And as you can see in this picture, I kind of further had to go through that text and modify it to make it a flat file that Mirth was able to ingest. And so then I wrote the code that went through and loaded, all the codes into a map. So it would take all the, the actual code and the description of the code and load it into a map. Then I set up a FHIR listener to ingest the messages, and then it would go through and check each one of those messages that came in from the HIE for an instance of cancer. And it would do that either searching for the word or any of the ICD-10, 9, or SNOMED codes. And so it was just kind of looking, does this encounter entail an instance of cancer? Like, is it diagnosed? And so that was, running on a server, but then it wrote it out to a flat file. If it did, it would have, basically the encounter ID, the patient ID, and whether or not it was a positive instance of cancer. The results showed, this is about, how many people ended up having, at some point, a diagnosis of it. So basically that flat file that was written out by Mirth was then run through Microsoft PowerBI, which did this visualization, which shows kind of, this is kind of, the district, what's going on in the distribution, how many people have it, and how many people don't. Alerting could be set up with this if it goes over a certain threshold, maybe within a certain region. You could use a heat map to maybe set off an alert and say, hey, this is going on, go pay attention to it. But that can all be automated very easily using Mirth Connect. So once you have that flat file, it just basically it had to be cleaned and then processed by Microsoft Power BI. Yeah, so overall, basically used OpenRefine to create the mapping and of the condition of the flat file. So basically, OpenRefine was used to create the cancer code, ICD-10 SNOMED link code to the actual description. And yeah, then it got processed through Power BI. Eventually, by reading it by North Connect, reading the codes into a global map, processing the FHIR message, creating a flat file that said, this is the encounter, this is the patient ID, and this is the whether or not they had it. And so it had to be reduced by, of course, encounter ID, because there can be several different encounters for one patient. Maybe the last one shows true, so it had to be reduced. And you want to make sure you have, you're not counting. So if the same patient shows up several times and it's like, yes, they have cancer, yes, they have cancer, yes, they have cancer, you want to only count that once. So it had to be, reduced by that, which it was clean through Spark. I had to write the queries that determined that those were the only cases that we had. One patient with any number of encounters that tested at least once positive for cancer. And then that flat file, which got reduced by an enormous amount because several different encounters were sent for any given patient visiting a hospital. It got reduced down to about 20% of what it originally was then run through Power BI. That's the results. Yeah, yep.